All right, so now 2.7 part 2 is where it gets a lot more fun. We're going to talk about these absolute values again, but now they're going to have all these different kinds of transformations. And if you remember back in 8th grade pre-algebra, transformations could be a reflection, it could be a shift left and right. So they're going to have a lot of stuff going. I could get more narrow, it could get wider. So it's a lot of fun. So let's first recap on the parent function. The parent function is just the y equals the absolute value of x. It starts at 0, 0. Okay, so it starts at 0, 0. The slope of this one, why do I keep doing that? The slope of this line is +1. The slope of this line is -1. The center point is the vertex. This right here would be your axis of symmetry, which means it cuts it in half. It's the same left and right. I'm actually going to skip this next one for the video to save time, but I'm going to go straight to this. So here is kind of your cheat sheet of how to do things with these graphs so you don't have to make a table and plot the points every time. Okay, so on this, the first one we're going to talk about is vertical translations, so that means up and down. If you have an absolute value and then plus a number on the outside, that means it's going up whatever that amount of numbers are. Okay, if you have a minus a number on the outside, that means it is going down. So outside is either up or down. Okay, so left and right, the horizontal translations are actually backwards. So just remember that it's kind of backwards of what you would think would make sense because of the absolute value sign. So if it is minus a number, then it's going right. If it's plus a number, then it's going left. And again, those numbers have to be inside the absolute value. So absolute value, x minus a number is right. Absolute value, x plus a number is left. Okay, the next ones we're going to talk about are shrinks and stretches. So if there is a number out front of the absolute value, that means it's a stretch, which means it's getting more narrow. Okay. If there is a number that is a fraction between 0 and 1, that's what that means right there, it is getting wider, and they use the word compression here. I don't like it. Let's say shrink. Okay, so stretch is like somebody took it and stretched it up. Shrink is whenever it's getting wider. The last one we're going to talk about is the reflection in the x-axis. So AKA it's going to be an upside down V. And we're not going to talk about this, and this one doesn't come up in this class, a reflection in the y-axis, so we don't have to worry about that. Okay, this next part is huge. I would definitely recommend filling this out because this is going to be kind of your cheat sheet, and this helps a lot of people. Okay, so if you have we have x plus 2 inside the absolute value. What is that transformation? So that is a shift, okay, and it's going left 2. Okay, if you don't believe me, look up at your little chart up above. Okay, now we have inside the absolute value x minus 3. That would be right 3. Okay, plus 1 on the next one on the outside of the absolute value. So now it's going to be either up or down. And since it's plus 1, that would be up 1. So it shifted up 1. And then on the outside, we have a -4 or -4, so that would be down 4. Okay, and now we have a fraction out front. So that means if it's a fraction between 0 and 1, that's going to be a shrink. And whenever you have, I just put 2 R's in shrink, my bad. Whenever you have a shrink, you always have to give a scale factor. So by scale factor is 1/2. So whatever the actual number out front is, that's where the scale factor. And that comes in handy later. You'll see when we actually start graphing them. Okay, and then this one, this would be a number bigger than 1, so that would be a stretch. And you also have to give the scale factor, so by the scale factor of 2. There's one more that does come up. I meant to add it to the notes, but I forgot. Let's add a little box there. So if you have y equals negative out front, absolute value of x, that is a reflection across the x-axis. Okay, again, please make sure you write that part down. It's really important. Okay, so now let's just talk about this graph right here, because I'm gonna talk to you about what shrinks and stretches look like. So first, let's look at this graph. So the vertex is at 0, 0. Okay, so it's not shifted at all. So, and then the slopes on the right side, that looks like it's positive 1, right? Up 1 over 1, up 1 over 1. On the left, the slope is negative 1, right? So this side, it's negative 1. Okay, this, if you remember from the last notes, this is just the good old-fashioned parent function. So y equals absolute value of x. Remember, call the parent function. Okay, so this is kind of what we base all of our graphs off, is how is it changed compared to this? Actually, a lot of your questions on the homework ask that. How does this compare to the parent function? And whenever they say parent function, it's this graph they're talking about. Okay, let's look at this one. Has the same vertex at 0, 0, but this time it's more narrow. So it looks like it has been stretched. So this is a stretch. Remember, we always have to find the scale factor for a stretch. So how you do that is you actually figure out what the slopes of the lines are. So on the right side, looks like they go up to right 1, up to right 1. So this slope would be positive 2. Then on the left, it looks like they go down to right 1, down to right 1. So this slope would be negative 2. And you'll notice on all of these absolute values, the slopes are always the opposites. Okay, so it should be the opposite numbers. So they're not going to have different numbers of slope. Okay, so since we have a stretch, your stretch scale factor in this case is 2. Your scale factor is always positive, FYI. Okay, so let's write the equation for this. It would be y equals, there's no shifts left and right, so we don't have to worry about that. We just have to worry about the scale factor, or the stretch. So you put your scale factor out front, so this scale factor is 2, absolute value of x. So that's what the equation of that absolute value graph right there is. Okay, let's do the last one. Looks like it hasn't been shifted, but it is wider. So wider is a shrink. And we need to find the scale factor is the slopes of the lines. So the slope over here is up 1 over 3. So this is positive 1/3. This one is down 1 over 3. So this side is negative 1/3. Okay, so your scale factor is 1/3. Okay, which makes sense. It's wider. The number out front needs to be between 0 and 1. So we're going to have y equals 1/3. You put your scale factor there. Absolute value of x. Okay, so on the next one, now we're going to actually start graphing them. They want us to do a few things. They want us to tell us what the vertex is, axis of symmetry, and transformations from the parent function. I like to start with the transformations. That's where my brain thinks. So let's talk about the transformations. What is happening whenever on this one where it has a +3 on the outside? Well, if you look back up at your chart, that means it's going up 3. Is anything else happening? I don't believe so. It's only the +3. There's no negatives, nothing else being added or subtracted. So that's it. So usually the graphs always start at where? 0, 0. But now it's being shifted up 3. So that right there is going to be our vertex. And in the directions, they want us to tell what the vertex is, so that would be 0, 3. All right. Now this is where you don't need to make a table and plot the points and do all that stuff. I'm going to teach you the shortcut. So we know there's no stretch or shrink. It's just like the parent function, but it's shifted up 3. And if you remember, the parent functions, the slopes were 1 and -1 of the lines, right? So we just kind of do that. So we're going to go up 1, right 1 a couple times. Then I'm going to go the other way, up 1, left 1, because that's the negative version. Draw a line with some arrows on it. You know how I like my arrows. Okay, and there she is. Way faster than making a table. The last thing they wanted to know is what the axis of symmetry is, and it looks like it's going to be this line, which is the y-axis right there. So your axis of symmetry is going to always be a vertical line. So whenever you say a vertical line, you have to say x equals and then the number. Please don't forget that part, because it will be wrong if you don't have x equals. If you just put the number, then you'll definitely get points off. So x equals, well, that line is at 0, so x equals 0 is your axis of symmetry. Here's a little cheat. If you always look, your x equals, it needs to be the x coordinate in your vertex. That's always going to be your axis of symmetry. So that's just a little cheat for you to kind of help you out a little bit. Okay, this next one, let's do this. So this one, let's start with the transformations. So you have a +3 on the inside. That means left 3. Okay, and then you have a -1 on the outside. So that would be down 1. So I need to go left, start at 0, 0, go left 3, down 1, put a point. Now, is there any shrink or stretch or reflection? The answer is no. So the slopes are +1 and -1. So let's do that. So up 1, over 1 in both directions a few times. Draw your line. So now let's do the vertex before I forget. That vertex looks like it's at -3, -1. And then the last piece is your axis of symmetry, which, remember, it's just x equals, and then it's going to be whatever this number is right here. So in this case, -3, which makes sense because that's a vertical line at -3, and that is the axis of symmetry. Alrighty, so now we have a stretch or a shrink. This is actually a shrink, my bad. So we have to identify the transformations. Since that's a fraction between 0 and 1 out front, this is a shrink. And remember, you have to have scale factor of 1/3. Okay, and you're going to see that how that comes into play in just a second. Looks like nothing else is happening to it, so that's it. So I'm going to have my vertex is not being shifted, so it's just at 0, 0, right? And let's go ahead and do my axis of symmetry to get it out of the way. So that is at x equals 0, right? Because it's the x coordinate of your vertex. Okay, so now the slopes of your lines is going to be +1/3 and -1/3. So you need to go up 1, right 3, up 1, right 3, and then go back to the vertex and go up 1, left 3, left 3. So as you can see, now it is a bit wider than the other two because it has a shrink. All right, last one of these graphings. So we have y equals -4 absolute value of x. So this one has two transformations happening. So it has the negative out front, which that means it's a reflection. So it's going to be an upside down V. And then it has the 4. So that is, since that's a number bigger than 1 out front, that is going to be a stretch. So it's going to be more narrow. Looks like it's not shifted left or right, so that would just be at 0, 0. Now, remember, it's a reflection. It's upside down, so we're going to go, and the slope of each line is going to be 4 and -4. So you're going to go down 4, right 1, down 4, left 1. I'm going to do it one more time just because. And so here is what the graph of that line looks like. Okay, last little bit. So we have the following. I'm only going to do, I'll do this one. I'll do two of them. Okay, so without graphing, identify the vertex, axis of symmetry, and transformations from the parent function. So they don't want you to graph it. They just want you to do, like, just look at the graph and tell me what's happening. Let's start with the transformations. X minus 2, that would be right 2. And then plus 3 on the outside would be up 3. Okay, so that vertex, if you start at 0, 0, and you go right 2, up 3, that coordinate would be 2, 3. Then the axis of symmetry, therefore, must be x equals 2. That's it. Okay, I'll do C, or letter B, I'm sorry. So it looks like this has a shrink. And then your scale factor, you must write that part, is 1/4. And then you have the minus 2 on the right side, so that would be down 2. Okay, so let's talk about the vertex. The only way it's being shifted is just by going down. The shrink does not affect the vertex. So go down 2. What's that coordinate? Well, that would be 0, -2. And then the axis of symmetry, therefore, would just be x equals 0. All right, might as well do the last one. Came this far, right? So, and I've got okay time. So y equals negative absolute value of x minus 4. Well, what's that negative out front mean? That's a reflection, right? So it's going to be upside down. Minus 4 inside the absolute value means right 4. Okay, so then your vertex starts at 0, 0, and it's shifted to the right 4. So that would just be 4, 0. And therefore, your axis of symmetry would just be x equals 4. All right, that is it for graphing absolute value. Make sure you do your homework so that way you get really good at this. It gets kind of fun once you get good at it. And the only way you're going to memorize all this stuff is if you just keep practicing. So, all right, thanks for watching. Have a great rest of your day.